Okay, today's notes are solving equations with variables on both sides. These were taken Tuesday, September the 14th in class. So basically what we're doing is we're trying to solve for x. It's a nice break on these equations really because we don't have any worded scenarios with these. These are only going to be just number and variable problems because of their nature. They can get kind of difficult and kind of lengthy. Although the caliber of students this year is so fantastic when it comes to solving equations, I think everybody will do wonderfully. So we're going to solve this first equation, and sometimes, not always, but sometimes I like to use the idea of the equal sign on an equation being like a wall, like it separates the two sides, the left side from the right side. And the reason why I like to look at that is because we've been doing lots of problems here lately that have combining like terms. And when the kids see the 5x and the 3x, I'm worried that sometimes they'll think that those are like terms they need to combine. Like terms would be on the same side of the equal sign or the same side of the wall versus letters that are on opposite sides need to be combined using regular equation rules. So since I'm moving the 3 and the x, the whole term at one time, I will do that by adding or subtracting. Since this is a positive 3x, I'm going to move it by subtracting. So I'll subtract 3x from both sides. 5x minus 3x is 2x. Bring down my minus 2 and my equals and my 4. Once we get to this step, it should be familiar territory. You should be able to solve the equation with 2 steps pretty simply. And like I said, most students are doing quite wonderfully on this. I'm going to add 2 because I'm still trying to solve for x. And I get 2x equals 6. If I divide by 2, then x equals 3. All right, let's look at the second one. 7k equals 4k plus 15. Again, with the idea of the wall, and you don't have to draw this when you're doing your problem, but for me it helps because I see which variables are where on each side of the equal sign. So I'm again going to take that 4k and move it over with the 7k. It's not a rule, you don't have to do that. For example, on this first problem right here, I could have taken the 5x and moved it with the 3x. It's perfectly fine to do that, but it's wonderful when we can get our variables on the left side of the equal sign. So I'm going to take this 4k and make it the opposite, which would be minus 4k. 7k minus 4k is 3k, and that equals 15. And a final little step of division will give me k equals 5. So there's the first two. All right, let's look at the next example. Whoops. Okay, example 3. Example 3 has a distribute, and again, most of the students now are being very comfortable recognizing the distributive property. You've got a number on the outside, and you're going to multiply it times both things on the inside. So I'll have 2y plus 12, because I'm multiplying the 2 times both things, equals 3y. Now this problem presents a little bit of a dilemma in that if I decide I want to move this 3y over to the other side with the 2y, in doing that, there's not going to be anything left on that side of the equal sign, and that's a problem when that happens because then students tend to stick the equal sign just in the middle of the problem and they end up missing the sign. So I think what I'd like to do on this one, instead of moving the 3y over, let's move the 2 to the 3. Even though it'll feel like the y ends up on the wrong side, that's perfectly fine. So we're going to take this 2y and move it over. And again, the reason we're doing that is because we didn't want one of the sides of our equal sign to be blank. We didn't want nothing to be left over there. So I'm going to bring down my 12 and my equals. Right here, if I do my math, 3y minus 2y is 1y. So I can basically say that my answer is y equals 12. But if you want to finish solving out, you can divide both sides by 1. Dividing by 1 doesn't change the answer, and your answer just comes out y equals 12. Now, example 4 looks very scary. However, when we did this in class today, most students did a brilliant job on it. They didn't really struggle with it at all. It's just recognizing all the parts and doing little pieces at a time. I give them a silly example of how if they get a pizza, they shouldn't try to eat the whole pizza in one bite. They eat it slice by slice. So that's exactly how we do these equations, is by doing one piece at a time. So I'm going to put my wall, because I really want to focus on working on one side of the equation at a time versus the other. So I'm going to start right here. I see like terms. Now these are like terms because they're both on the same side of the equal sign. However, when I put 5b and 3b together, I need to be super, super careful that I don't automatically think that it's 8b. This is a negative 5b, and that's how you have to think about it. I know that sign is a subtraction sign, but when you're dealing with that term, you have to consider that sign on that term. So it's negative 5b plus 3b, which would be negative 2b, and of course our 3 is still out in front. Okay, now let's go over to the other side. There's a distribute that I need to do. I need to take that negative 2, multiply it times the 1, and times the negative b. When you're distributing a negative, please be super, super careful that you get your signs correct. So I'm going to go ahead and bring this negative 2 down because I haven't done, this little guy right here, I haven't done anything with him yet. If I distribute negative 2 times 1, I get negative 2, and negative 2 times negative b, I might even think about that like it's a 1b. That would be plus 2b, because a negative times a negative is a positive. So I did my distributing, but then after I did that, I notice I've still got things over here. Negative 2 and minus 2 aren't really like terms, but you can think about it that way. They're both numbers, so you can go ahead and put those together. Negative 2 minus 2 is negative 4. Be sure to utilize your calculator if you need to, if you're having integers trouble. A lot of people think negative 2 minus 2 is 0, but they're both negative. Technically, it would be negative 2 plus negative 2, so that does equal negative 4. And then to finish up this little guy, let's get our variables together. I'll take this 2 right here, 2b, and move it over with this one. Now these cancel because one's positive and one's negative. I'll bring down my negative 4 and my equal sign. Right here I've got two negative values that I'm adding together just like I did up here. So I'll have negative 4b, and then of course I have a 3 out in front. Now we're to the step where we just got a simple two-step equation. Just solve it for b. I'll move the 3 first. I'm going to subtract the 3 because this technically is a positive 3. I'll bring down my negative 4b. Be careful, don't let that little minus sign disappear. That goes with the 4. And that equals, this math right here is going to be negative 7. If I divide both sides by negative 4, finally to finish up on this big O problem, I'm going to get b equals 7 over 4. A negative divided by a negative is a positive. If you want to write your answer 1.75 or 1 3/4, any of those three answers would be perfectly acceptable. All right, last two. Now there's always exceptions to the rule, and both of these problems show you a small exception to the rule. Now I'm going to start out just like I did on the last one. I see I have like terms. I have a 1x and a minus 6x. That will give me negative 5x plus 4. On this side I've got a 6 and a minus 2, so that gives me 4 minus 5x. Now I'm going to put my x's together. So I'm going to take this minus 5x over here and add it to both sides. So those cancel, but then when I come over here on the other side to simplify, those cancel also. All my letters have disappeared from the problem. So I'm going to write down what I have left. I've got 4 equals 4. Well, is that a true statement? Does 4 actually equal 4? And of course it does. So what that means is there any number, any real number that I could think of that I could put in place of this x and this x and this x, the same number in each one of those x spots, it's going to make this problem true. That means that there are many real solutions. I think in class we may have said all real solutions. That's fine. You can write many real solutions or all real solutions. Basically, it's just any real number will work for that problem. The way they have it set up, any number you can think of is going to work. So that's why our letters canceled out. If your variables cancel and you end up with a true statement right here, your answer is all real solutions, or you can say many real solutions. Finally, this guy. Let's do some simplifying. Let's combine like terms. Putting those two together, you get 1x plus 6 equals negative 17 plus, I'm going to put a little 1 in front of that x. I'm seeing a pattern here. I know if I minus my 1x there and there, not only is it going to cancel here, but it cancels there also. Now, when I bring down my answer this time, I've got 6 equals negative 17, and that is obviously not true. 6 does not equal negative 17. So on the first problem I had all real solutions or many real solutions. On this one, I have none. No real solutions. There are no real numbers that you could put into this problem that would make it work. So your letters cancel out on both sides, but you come up with a value that is not true. And guys, that is solving equations with variables on both sides. Thank you.